In this video, we're going to be doing all of our example problems on Lewis dot structures. So what you're going to want to have out is your rules to follow when making Lewis dot structures, and you can follow along as we solve all of these problems together. Our first problem is going to be HCl, and the first thing we need to do is identify how many valence electrons hydrogen has and how many valence electrons chlorine has. So on the periodic table, you can take a look. Hydrogen has 1 valence electron, and chlorine has 7. So you can draw your Lewis dot structures like this of each one. And if you count, we have a total of 8 valence electrons. So when we start and when we finish, we want to make sure we have a total of 8 valence electrons. So what's going to want to happen here is hydrogen wants to form a bond. It wants 2 valence electrons. Chlorine wants another one. So we are going to make a covalent bond right there. And if we count up our electrons around each atom, hydrogen has 2, so it's happy. Chlorine has 8, so it's happy. So 2 thumbs up there. Last thing we got to do is check if our total number of valence electrons stayed 8, and there's 8 still. So we can draw this out, and it would look like H single bond to a chlorine, and the chlorine has its lone pairs all around it. So that's what HCl would look like. All right, so let's do another example. The next one is going to be H2O. So this will be water. And so let me grab out 2 hydrogens here. And 1 oxygen. And let's count up our electrons. So we know hydrogens have 1 valence electron each. And oxygen will have 6. So we could think, first when looking at H2O, this 2 right here tells us how many hydrogen we have. So I guess that's the first thing we should think about. So we got 2 hydrogen. So our hydrogen have 1 valence electron each, and we have 2 of them. So we get 2 valence electrons from our hydrogen. And from our oxygen, we just have 1 oxygen, and it has 6 valence electrons. So our total, when we finish this whole problem, our total valence electrons will be 2 plus 6, 8. So we could think about this. Our next thing we got to look at is what element will be our central element, our central atom in this. And we can answer that by which one wants to form more bonds. So hydrogen just wants to form 1 more bond because it wants 2 electrons. And oxygen wants to form 2 bonds because it wants a total of 8 electrons. So oxygen wants to form more bonds, so it is going to be in our middle. So let's put oxygen more in the middle and our hydrogen on the sides. And then we could start forming some bonds. So if this hydrogen wants to bond with this oxygen, that could happen. And then we could connect this hydrogen to that oxygen, and there we go. We can check to make sure everything is happy here. This hydrogen has 2 valence electrons, so check there. This hydrogen has 2 valence electrons, so check there. Let's count our oxygen, 1, 2, 3, 4, 5, 6, 7, 8. That oxygen's happy. The last thing we have to do to make sure we didn't just add any extra electrons to our molecule is by counting our total. We got 1, 2, 3, 4, 5, 6, 7, 8. Same as what we started with. So we're looking good there. This will be our answer. So we can draw it like this, H, O, H. And if you drew it like something else, that would be completely okay too. You could draw it like this. That would have been completely okay. So either of these works. As long as your O has a bond with both the hydrogen and has 2 lone pairs on it. All right, let's jump into another example here. We got CCl4. So in this example, we got carbon, which is our C. And carbon has 4 valence electrons, so we'll write that out. And we have Cl, and we have 4 of them. You can see that 4 right here. That 4 tells us we got 4 chlorine, and chlorine have 7 valence electrons each. So we're gonna have a lot of valence electrons here. So 28 just from our chlorine. So our total valence electrons is 32. That's how much we start with. That's how much we need to end with. So let's bring out our carbon with its 4. And we got 4 chlorine. Let's see if we can fit 4 chlorine out here. One. Might need to zoom out a little bit just to get all of them here. And while we're doing this, we should be thinking, what element's going to be our central element? Is it going to be a chlorine, or is it going to be the carbon? So we got to think, which one wants to make more bonds? So chlorine has 7 valence electrons. And at 1 state, so chlorine just wants to make 1 extra bond. It just wants to share 1 of its electrons. Whereas carbon wants to share all of its electrons. It wants to make 4 more bonds. So carbon, because it wants to make more bonds, we're going to put it in the middle. So let's change some of these spots around. Let's move this chlorine over to the side, and let's put this carbon in the middle. And you can see why you want to count all these valence electrons, because it's not hard to add an extra one or actually get one slipped in there. All right, so let's start making some bonds. Let's start bonding these chlorines with the carbon. So let's start bonding these chlorines with our carbon. And once the chlorine makes a bond with the carbon, it's happy because it has 8. So we can see 1 bond here, 1, 2, 3, 4, 5, 6, 7, 8. That chlorine does not want to make any more bonds. And this carbon, 1, 2, 3, 4, 5, still wants to make some more. So let's keep bonding with these chlorine. So we'll put this one here. Move this one down to the bottom right here and bond that to the carbon. We have to zoom out quite a bit here. And then we'll bring this one down to bond over here. And if we count everything up, we can see we'll count the bottom one first. 1, 2, 3, 4, 5, 6, 7, 8. That chlorine's happy. 1, 2, 3, 4, 5, 6, 7, 8. Yep. 1, 2, 3, 4, 5, 6, 7, 8. That one's happy. 1, 2, 3, 4, 5, 6, 7, 8. Check. And then we just have to check our carbon. 1, 2, 3, 4, 5, 6, 7, 8. Check. And then we have to make sure that we have 32 in total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So this is what it's going to look like. So let's move this off to the side, and we could draw what that looked like down here. So it would be the carbon in the middle, single bonded to chlorine on every side. And then we have to put those lone pairs on each chlorine. So that is what this would look like right here, CCl4.